Welcome friends. In last lecture, we have seen the power flow through the transmission line. Now, in this coming few lectures, we shall see how power flow can be computed using analytical method as well as graphical method. So, in the last lecture, we have seen active power. We have seen active power at receiving end is equal to it's given by this expression given by PR is equal to PS into VR by B cos beta minus delta minus A by B PR square cos beta minus alpha. Similarly, we get the expression of reactive power as well. Reactive power at the receiving end, QR. So QR is equal to PS PR by B sin beta minus delta minus A by B PR square sin beta minus alpha. So we have derived these two equations. So this is equation number 1, this is equation number 2. From equation 1 we can write PR plus A by B PR square cosine of beta minus alpha, that is equal to Vs into VR by B. Similarly, from equation 2 we get QR plus A by B PR square sin beta minus alpha, that is equal to Vs into VR by B sin beta minus delta, and with the first equation it should be cosine of beta minus delta. So now let us assume x is equal to PR plus A by B VR square cosine beta minus alpha phi is equal to QR plus A by B PR square sine beta minus alpha, and we consider R is equal to Vs VR by B. So from these two equations, what we can write? So we have x is equal to R cos beta minus delta, and y is equal to R sine beta minus delta. So with this, we do x square plus y square is equal to R square, which is cos square beta minus delta plus sine square beta minus delta, that is equal to R square. So what we end up doing is x square plus y square, that will be is equal to c square. So interestingly, we found active power and reactive power flow, and this is a equation of a circle. Where radius of the circle being equal to radius of the circle being equal to R, or rather, sorry, this should be R. Okay. C should be R. So R should be is equal to Vs into VR by B. This is the value of the radius. Whereas the center is, the location of the center is how much? So x coordinate being minus a by b to VR square cos beta minus alpha, whereas y coordinate lies at minus a by b VR square sine beta minus alpha. So we have circle that has a radius of Vs VR by B. We have a center located at x coordinate, that is minus a by b VR square cos beta minus alpha, and y coordinate it's minus a by b VR square sine beta minus alpha. So from this equation, so this should be my location. So this should be my location. One x component is this and y component is this. So if we have our x coordinate and y coordinate like this, so we have so if we have our x coordinate like this, and if we have a y coordinate like this, this is x and this is y. So you see the center is located on the third quadrant because both are negative. So around some point near this, around this point, it is the location of the center. It is the location of the center. So this should be the location of the center, and this line represents a by b VR square. This line represents A by B VR square. This angles happens to be beta minus alpha. So this much is minus A by B VR square cos beta minus alpha, and this much length is your y coordinate, and it is equal to A by B VR square sine beta minus alpha. Now we have a load line. We have a load line like this. It is equal to VR into IR, and this should be equal to phi R. That is the reactive. That is it is the receiving end power factor angle. Phi R is receiving end power factor angle, and this line is the radius. This line is the radius. It's line joining from the center to this tip. So this is actually VS VR by B. So this tip should be traced like this. So it represents the of a circle. So essentially this represents VR IR cos phi R, which is equal to PR. That is active power demand at the receiving end, and this essentially computes VR IR sin phi R, which is equal to QR, that is the reactive power demand at receiving end. So if the load has been operated at some different angle, if the load has been operated at some different load power factor angle, let us say this is the power factor angle, new power factor angle, phi R new. So accordingly your active power demand will be only this much and reactive power demand will be this much. So in this way by looking at the tip of the circle or the locus of the circle, various information can be obtained using this diagram. This is called receiving end power circle diagram. This is called receiving end power circle diagram. So it essentially the locus or active power and reactive power combiningly makes the equation. It is in the form of x square plus y square is equal to r square, which is the equation of a circle. So the locus of the circle essentially tells you or essentially indicates the loading condition, at which load what is the power factor angle, and accordingly what is the necessity of active power and as well as reactive power. So this is called receiving end power circle diagram. Similarly, the same power circle diagram can be drawn for the sending end also by applying or by approaching in the same way. So this is the analytical approach of obtaining power circle diagram. This is the analytical approach of having the power circle diagram. In the next lecture, we shall see how this power circle diagram can be obtained using graphical way. by graphical method we can achieve, we can have this recipient power circle diagram quite effectively. Okay, so I am ending with this till now, so we shall continue in the next lecture. Thank you.